Used plastics are not waste, but rather a raw material. Nevertheless, enormous quantities are still lost, mainly through incineration and landfill disposal. As a result, there are increasing political initiatives worldwide to bring more plastics into a circular economy through recycling. More on that later. How big is the problem? Based on current assumptions, more than 400 million tons of plastics are produced every year. Yet today, recycled raw materials are reused for less than 10% of this amount. A large proportion is therefore not recycled. That is an enormous waste of resources. One promising technology for recycling even heavily contaminated and mixed plastic waste is pyrolysis. The starting material consists of plastic flakes like these. In the pyrolysis process, the long hydrocarbon chains in the plastic are thermally broken down and converted into a liquid oil, pyrolysis oil. In principle, this oil could serve as a raw material and replace petroleum-based raw materials or fossil naphtha. However, the oil contains various impurities because of food residues, mixed plastics, and additives. This means it cannot be used directly in a steam cracker as a replacement for petroleum-based raw materials. European steam crackers are multi-billion euro facilities that have been optimized for specific naphtha qualities over decades. The more precisely the pyrolysis oil matches the respective steam cracker, the higher the yield. This both reduces environmental impact and improves economic viability. The central challenge is therefore figuring out how to upgrade contaminated pyrolysis oil so that it can once again be used on a large scale as a basis for new plastics. We at Evonik began addressing this question more than 6 years ago. Our advantage was that, although we do not operate pyrolysis plants ourselves, we are specialists in processing raw materials for petrochemical applications. We therefore have extensive expertise in processing naphtha products for use in steam crackers. Our products have long been used to selectively remove impurities from oils in petrochemical processes. These substances, called adsorbents, specifically bind impurities. The process began with intensive analysis, comprehensive literature reviews, conventional laboratory testing, and extensive experimental series. This made it clear which approaches might be used to effectively separate the various impurities with the aid of adsorbents. What exactly are these impurities? Our analyses have shown that pyrolysis oils are more commonly contaminated with chlorine compounds, other halogens, silicon, heavy metals, and nitrogen compounds. These unwanted substances cause considerable problems in petrochemical plants. For example, they can damage catalysts, cause corrosion in plants, and impair product quality. Without targeted processing, the use of pyrolysis oil would therefore remain limited to small dosages. Our colleagues at the site in Little Rock, Arkansas, took on the challenge of developing a tailored solution for this. As a first step, they focused on adsorbents that had worked well in the purification of conventional oils. However, it was not possible to sufficiently bind the organic chlorine compounds in this way. They were too big for the cage, as the colleagues put it. Because of their sheer size, these molecules did not even reach the binding sites of the adsorbents. The decisive step was to combine catalytic and adsorption functions in a single product. This combination converts the organic chloride compounds into simpler inorganic chlorides. These are easier to bind and can therefore be reliably removed. This innovation is now marketed under the product name Purocel 505. Here is a schematic illustration of the purification process using Purocel 505. The pyrolysis oil is fed into the top of the adsorption vessel. When the hydrocarbon chains contaminated with chlorine come into contact with our Purocel, the chlorides are separated off in a catalytic reaction and adsorbed. This allows more than 2/3 of the contamination to be removed. However, the right chemistry is not the only important factor for operators of pyrolysis plants. What matters is that solutions can be integrated easily into existing facilities. It was therefore clear to us, for our innovation to be particularly successful on the market, it had to work without major investments or lengthy conversions and shutdowns. That is precisely why we developed our rocket system. This modular, pre-assembled purification unit can be integrated flexibly into existing infrastructure without major conversions or lengthy shutdowns. This lowers investment costs, reduces operating costs, and facilitates the adoption of pyrolysis oil. This system uses Purocel 510, a product based on the aluminium ore bauxite, which is also recyclable. In applications with particularly demanding requirements, an additional hydro-treating step follows. In this process, the remaining impurities, here alongside the chlorides shown in yellow or silicon shown in green, are removed via the gas phase through the use of hydrogen at high temperatures. This makes the oil more stable and thermally robust. That is a prerequisite for use in steam crackers that produce raw materials such as ethylene or propylene, but now with the attribute recycled. The recycled content in the plastic product is verified and certified through mass balance accounting. Evonik deliberately positions itself in chemical recycling as a systems partner. We do not offer a single solution for a special case, but rather a modular system for different plant sizes and process requirements. You are already familiar with the rocket system. The adsorbents are ideally suited for use in smaller facilities. Alternative purification options, such as hydrogenation, would involve excessively high investment costs and would not be economically viable. For larger-scale facilities, we offer two complementary technology solutions. First, the efficient removal of selected impurities, and second, integrated solutions, such as hydrogenation catalysts. This is then economically viable. This means Evonik is well positioned to meet the growing demand for chemically recycled materials. Some of you may now be wondering where these growing markets actually are. Is recycling only a European topic? Clearly not. Both the US and large parts of Asia have launched legislative initiatives to advance chemical recycling. For example, China recently launched major programs to expand plastic recycling. By 2030, 20 million tons of plastic are to be chemically recycled each year. In the US, alongside voluntary commitments by industry, there are various legislative initiatives that rely on chemical recycling. And in 2025, the EU introduced regulations for not only single-use plastics, but also the automotive sector. These stipulate that from 2032 onwards, new vehicle types must contain at least 15% recycled plastic. From 2036, this will increase to at least 25%. Alongside mechanically recycled materials, chemically recycled materials can also be used here. For example, in safety-critical applications such as brake lines. What does this mean for industry and society? First, there is the effect of sustainable innovation. We replace fossil raw materials with existing materials. This benefits the climate because plastic waste is not incinerated and less crude oil needs to be extracted. In addition, it strengthens the resilience of our industry. In the coming years, steam crackers will come under economic pressure because of declining fuel consumption. However, they are indispensable for the production of starting materials for medicines, plastics, and everyday materials. That is why it is important to preserve them. With the growing feedstock stream from pyrolysis oil, the petrochemical industry gains access to a defossilized petrochemical feedstock stream. In recent months, we have also seen how strongly the global economy depends on individual regions for certain raw materials. But we could become more robust and independent by supplementing fossil raw materials with materials already circulating within our own economy. This makes us less dependent on fluctuating imports and uncertain supply chains. Of course, the solutions of Evonik alone will not achieve this, but they are an example of how sustainability and resilience can be considered and implemented together along key value chains.